And it's now time to pass the screen and microphone to Kelly. Kelly Hyde has worked with Professor Anurag Sharma on his VirtYS project. Kelly is PhD candidate at the University of Pittsburgh, and he will be sharing the results of his work on the regressive costs of drinking water contaminant avoidance. Please, Kelly.
Thank you, Dr. Nizalova, and thank you everyone for coming. So as she just mentioned, the title of my talk is The Regressive Costs of Drinking Water Contaminant Avoidance, and this is part of a broader research agenda on the distributional implications of environmental shocks. Really looking forward to any comments you may have on this. Between 9 and 45 million Americans are exposed to contaminated drinking water in any given year. The EPA enforces maximum contaminant levels, or MCLs for short, for 83 different compounds with a variety of health effects. They can have cardiovascular consequences, respiratory, for the case of infants particularly, could be acute health conditions or even death. And these contaminants can enter the water through various sources: industrial processes, soil runoff for some naturally occurring organic compounds, or improper treatment techniques at the water utility if there's excessively high residual disinfectant level. That's another potential violation. Overall, regardless of what contaminant it is, whenever these maximum levels are exceeded, the utility is required by law to inform their customers as soon as they can, within 2 weeks of the violation occurring through a test. And while those customers wait for the water supply to return to compliance, they can purchase bottled water and filtration devices to avoid contaminants in the interim. And we know that they do this from existing literature in economics, health economics generally. People increase their purchases of bottled water or things like filters, water pitchers that you put in the fridge where you can filter out contaminants, maybe even lead, as a way of avoiding those contaminants until the utility manages to remove them from the supply. But this cost looms larger for poorer households. So these costs don't scale with income. The cost of going to the store, unless there's a program in place to explicitly distribute bottled water and filtration devices to poor households, which is very uncommon, the price is the same for everyone. So if everyone has to purchase these devices to avoid, that's going to make up just mechanically a greater share of income and disposable income specifically for poorer households. For example, in Flint, Michigan, which is kind of a poster child for water issues in the United States this decade, the state was spending $22,000 per day on a free bottled water distribution program to residents. That was an example where they actually did distribute water for free to affected residents, and the costs mounted very quickly. According to a market study covered in Business Insider, the average cost per gallon of bottled water was $1.22 in 2012. And this is skewed a bit upward by single bottles. So a lot of water purchasing in the United States is, you go to the checkout line at the grocery store and you grab a single bottle of water out of the cooler there. And those are very, very expensive per gallon, up to $7.50 per gallon because of the convenience charge. If you remove those, it's a little bit more modest, but still relatively high per gallon cost of 49 cents, especially when compared to tap water, which costs on average 0.4 cents per gallon. So anywhere from about 100 to 300 times more expensive per gallon. As a way of putting some magnitude on this with the back of the envelope calculation, family profiled by CNN in 2016 in Flint, Michigan, was using 151 bottles per day for consumption, cooking, cleaning, all of that. That equals about 20 gallons, which is about $9.80 or up to $24.40 if you use this more skewed average per day. So very significant cost to the household, especially if that household is budget constrained. Overall, budget-constrained households face a choice. They either risk exposure to the contaminants and save this money, allow them to dedicate this money to other things, nutritious foods, things like that, or they do purchase this avoidance, and as a result, they have to potentially forego other types of consumption. That gets me to my research question, which is, how do the economic consequences of water quality violations differ by household income? And a secondary question to that, in terms of a very specific potential economic consequence that I've hinted at a couple times, does poor quality water supply increase the risk of food insecurity among poor households? The first thing I'm going to show you is just a correlation between food insecurity rates in the United States and the prevalence of water quality violations since 2009. So to define the data that I use to define those measures, first I have a panel of health-based water quality violations from the Environmental Protection Agency Safe Drinking Water Information System, and that spans from 2009, which is when this database started to be publicly available, to 2016. The definition of health-based is just any violation that's expected to have adverse health consequences for consumers, either acutely or in the long term after long repeated exposure. Importantly, this does not include monitoring and reporting violations. So in this data set, there are a lot of violations that just mean the utility didn't submit a test result by a particular deadline. In those cases, we don't necessarily know whether there's something wrong with the water or not. It could be just, bureaucratic failure to report the violation. The water could be fine. So I restrict to only the cases where we absolutely know something is wrong with the water that needs to be rectified. This data set includes both the date that the public notification was requested by regulators, which is required by law. There are fines attached to failing to notify affected customers, and then the date that compliance was ultimately achieved. And I characterize any violation between these two dates as active. These are essentially the start date and the end date of a particular water quality violation. Then, to get a measure of household expenditure, particularly on groceries and other nutritious foods, I have a panel of household purchases from the Nielsen Home Scan Consumer Panel, and that's from 2004 to 2016. This is a nationally representative panel with over 100,000 households in it in total. About the coverage is about 50,000 to 60,000 households per year. And importantly, it includes demographics on these households. I use the household size and the household income, both of which are reported in the panel, to classify households as above or below 200% of the federal poverty line. This is my measure of whether or not that household is likely to be budget constrained in their grocery purchases. 200% of the federal poverty line is a common threshold used for means testing in food programs, or similar cutoffs like 185%, around there. And finally, to get a measure of the nutritional value of these household grocery purchases, I have UPC level nutrition facts data from the USDA Food Data Central. So this associates with each product code, the barcode that you scan in order to check out a product at the grocery store. This has all of the information that you would see on the nutrition facts panel for that product, for products sold in the United States. This is a map of where these water quality violations are occurring at the county level. So a lot that's in this map is echoing what was found in that PNAS paper by Mbora Allaire and co-authors. In particular, this area with Texas is a very high concentration of water quality violations. The southern Midwest and the Southwest are a real hotspot in terms of water quality issues. And then you see some other hotspots throughout Appalachia and in Florida as well. And for this map, so that you can see the variation, I top code the number of violations at 20. So there are some counties in the sample that have as many violations in the sample period as 130. That's the maximum. But just to make sure that you can see a smooth variation across counties, I top code this at 20. Then to kind of superimpose one map on another to show you the correlation spatially, this next map is the map of the food insecurity rate. So this is the 2017 food insecurity rate from the Mapping the Meal Gap project of Feeding America, one of the biggest charities in the US focused on hunger and food insecurity. And this is in quintiles. So you see the same areas in Texas particularly, and the southern Midwest that were hotspots for water quality violations are also hotspots for this food insecurity issue. And overall, if I just do a naive correlation between these two measures, I find that one additional violation is correlated with a 1.4 percentage point increase in the food insecurity rate. And this is a highly statistically significant correlation. But obviously, this alone is not enough to determine causality. There are many reasons, I'm sure you can imagine, that these two things might be correlated. So my research question is essentially, is there an underlying causal relationship? Is this correlation, at least in part, causal because of the downstream economic consequences of water quality violations? This is my empirical strategy. For each household, I calculate 3 measures, and these are going to be my 3 dependent variables. So I have the total expenditure per day that's reported to the panel. I have the calories purchased per household member per day as a measure of how much these people are eating. And then finally, avoidance. That's purchases of bottled water, filtration devices, containers like Brita pitchers and things like that as a share of overall expenditure for the household. Using these dependent variables, I have 2 complementary specifications. I have first a panel fixed effects regression with an active violation indicator, where active violation is defined, as I said before. And then I'm going to do an event study specification of the first recorded violation in the data. I'll explain why when I get to that. Ultimately, in each of these specifications, I'm going to be comparing the treatment effect for households below 200% of the federal poverty line to households above 200% of the federal poverty line. So it's a difference in that way, or even a triple difference if you consider the active violation treatment variable. So I'll start with the panel fixed effect specification. This is just the regression model. The energy is defined, as I said before. Active violation in period T for household I is a dummy variable that equals 1 if a community water system in the county of household I has reported an unresolved health-based water quality violation in month T, and it's 0 otherwise. Then below 200% federal poverty line is a dummy variable for that indicator as well. And note that I exclude the non-interaction term in this textual representation of the model just because it's collinear with the household fixed effects. So that's differenced out by the household fixed effects. I include household year and month of year fixed effects in this regression to absorb both household level heterogeneity and time varying heterogeneity in these measures. Particularly, this is going to pick up any idiosyncratic differences in the panel over years, because the panel is packaged yearly and the sample changes annually and all of that. So I definitely want to absorb any of those idiosyncratic fixed time variation. And finally, I restrict the sample to areas that experience at least 1 violation during the sample period. So you might think that there's a selection in terms of where these water quality violations might happen. Maybe it's necessary for particular industries to be there or something. And so I don't want to compare on the extensive margin. I'm comparing on the intensive margin of water quality violations, or using the timing of those water quality violations as my shock. And this table shows the results of that specification. So in each case, a highly statistically significant coefficient on the interaction between the active water quality violation and this measure of poverty. For avoidance, it's about 28 hundredths of a percentage point relative to a mean of about 0.64 percentage points, 0.65. I did put a little footnote there just to note that many observations for that particular measure are 0. So it's a somewhat left skewed distribution, which explains maybe why this coefficient is on the smaller side, but still statistically significant. So this first column confirms that these costs, as we expected mechanically, are looming larger for poor households as a share of their disposable income. Then the second is expenditure per day. And this differentially declines for poor households by about 24 cents per day. Or if I extrapolate that out to a month, it's about $7 per month. This is relative to a mean of about $12 per day for households that are in this panel. So this suggests that
sorry, you have, like 1 minute. I'm sorry.
Oh, that's okay.
Yes, please.
Yes. So then finally, for calories, I get a decline of about 50. Again, if I extrapolate that out to a month, it's about 1,500 per month, suggesting that a way of thinking about that is that an average household member goes potentially hungry for about 1 day in the month, differentially relative to wealthier households. So I'll skip forward a little bit for time. I run a panel or an event study to answer some of these questions that are not answered by the panel fixed effects regressions. And I'll skip those. These are just specification things about the event study and show you the graphs. So this is for avoidance. You see that after time 0, there is an increase in avoidance, particularly around the 6th month of an active violation. So the longer these violations stretch out, the more avoidance ends up being purchased in this household. This is for expenditure, same kind of thing. The effects accumulate the longer the violation lasts. So the strongest effects are really going to be for these drawn out violations that take a very long time to resolve for the water utility. And then finally for energy, again, same thing. Effects start to accumulate around month 6, and we see that decline graphically there. So there are additional robustness checks I've run. I've done this at the zip code level instead of the county level, similar results. But I do want to be transparent about my limitations. So I don't know the specific water supplier of each household. So I know that a water supplier in an area was affected by a water quality violation, but I don't know if it's that household's water supplier. So this is going to attenuate these estimates. Also, I have food purchased at restaurants is unfortunately not observed in this. It's possible that households substitute toward fast food or something like that. That's a limitation of the panel data set. And I may also underestimate avoidance expenditures if water filters are purchased at venues that don't enter my data. Just to conclude, during an active water quality violation, poorer households' expenditure on grocery products differentially decreases by about $7 per month. But this is very likely an underestimate because this is an intent to treat where there's uncertainty as to whether or not the household is actually affected by these violations. Calories purchased per household member per month declined by about 1,500, which is a large share of the daily recommended number of calories. And overall, these findings suggest that the indirect effects of water quality shocks through economic channels may contribute to food insecurity and poor nutritional outcomes. Thanks.
Thank you very much, Kelly. If you could please stop sharing the screen so we can see.
Yes.
Thank you very much. We have 2 questions. I would hold on my questions for later. Alfonso Flores Lagunas, could you? Yes, please.
Yes. Yeah, sure. Very, very interesting presentation and topic. Thank you. So the question that I have is that I am not sure if you're able to control for household size because due to hardship, the size of the households, particularly poor households, might vary over time. And I don't know how that might be also impacted by the water quality issues, etc.
Yes, so I do have those demographics in the panel are updated on an annual basis. So I would observe with a little bit of a delay, unfortunately, if I wouldn't observe the exact month that an additional household member joined. But I could look at heterogeneity by that at the annual level. yeah, I think that's going to be relevant, particularly because that's the denominator of a lot of my dependent variables. So yeah, I can definitely look into that. Thanks.
And a quick suggestion, if I may, something that appears to me would be very interesting is to look at the heterogeneity by race and ethnicity. For several reasons: poverty rates, food insecurity, exposure varies by in that dimension, and also household size and so on. Location as well.
Absolutely. Yeah. So I have done, actually for a different paper, some analysis of the different incidents by race, and definitely pulled in some of the environmental justice literature, that there definitely is a disproportionate incidence of these water quality violations by race, by socioeconomic status. And I do have that information as well, at least for the heads of household. I have the race of the both male and female heads of household if each one of those is present. So I could look at that as well.
Great, thank you.
Thank you.
Other questions? Well, maybe I can ask. Oh, please, Almas.
Sorry, you go first.
No, please.
So my question was, it would be interesting to use, instead of this dummy variable for poverty line, to use relative to mean or median of a smaller group. So it means you allow for variation in this poverty line by location, and that gives you much more informative estimates than using a dummy variable.
Right. So essentially like a cost of living adjustment sort of thing, or
Yes, because price develops differently from one location to another.
yes. Yeah, definitely. I definitely want to pull in more information about prices into this. That's I've also received a kind of similar suggestion looking at whether or not these effects could be partly driven by price variation for the avoidance. If there's a major demand shock to avoidance, then we might see an explosion in prices of bottled water or something like that. But yeah, so I can say overall that on a national level, these water quality violations, and you can kind of see it from the map if you like know where these areas are, they disproportionately occur in rural low-income areas, which is kind of interesting because a lot of the environmental literature on air pollution is the opposite, where air pollution is typically more of an urban phenomenon, whereas water pollution is more of a rural, low population density, low income phenomenon. But there are definitely exceptions to that, where, you know, there, even here in Pittsburgh, we had a major issue with lead about a couple of years after Flint. And yeah, it would be informative to, there are definitely areas of Pittsburgh where the average income is significantly higher than the national average. So thank you.
I think my question is a bit related to Alma's, but in a different way, also about geography, basically. So I just wondered whether, you know, the likelihood of the violation occurring depends on the region, and therefore other geographic things that may have an impact on, you know, climate things, climate characteristics, which may. So I was just thinking, maybe if did you control for geography for region, because that might have addressed both our questions, I think.
So I do have the household fixed effects in there, and I do restrict the sample to only households that remain in the same location over the panel, because I was a bit concerned about the possibility of moving, differential moving out of areas that experience the water quality violations. So I guess to some extent the geography would
calling for that to some extent. Yeah,
that would be absorbed partially by the household fixed effects. Yeah, but I think, and that's a comment that I've received also, pulling in more about like why these violations happen in the first place, as a potential way of explaining if there are any, because I have this effect that I estimate of decreasing expenditure, but it's the mechanism remains to be found. Like, what exactly is happening? Is it all avoidance? Are there maybe labor market dynamics that are happening if, you know, maybe a water quality violation occurs and a plant is closed because they're polluting too much and they're fined, and then everybody gets laid off, you know, something like that. And that's all work that I'm planning to do in the future. I definitely want to look more into that.
Right. Thank you very much. I would like to thank to all the participants for coming and participating in this webinar.